This next story impacts people around the world, but some of the top experts are right here in Oak Ridge. You've probably heard that fish can contain mercury. It's why pregnant women are advised not to eat large amounts of it. A team of researchers at Oak Ridge National Lab has come up with a way to monitor particles in water and follow them. This is helping track mercury levels. It's also guiding the future in some ways.
This is the Upper East Fork Poplar Creek watershed.
It's a focus here at the Aquatic Ecology Lab.
We've got a little setup here.
Researchers are studying how mercury flows and changes through our waterways.
Transporting from the landscape to stream.
It's the only metal that is liquid at room temperature.
Mercury is a really interesting element.
And it has contaminated soil, buildings, and water at the Y-12 National Security Complex.
Our biggest dose of mercury actually comes from eating contaminated fish.
It biomagnifies, meaning it becomes more and more concentrated as it moves up the food chain, absorbing into the tissues of its consumer. That can present environmental and health risks. Researchers are constantly testing the levels in the water and fish. And yes, they do bond with their work, like this sturgeon, with just one thing.
That's lucky.
It's really tough to get rid of mercury once it's here.
Some of these properties that make it so interesting to use actually make it very difficult to remove from the environment. So once it contaminates the environment, it's very challenging to remediate.
It was used at Y-12 starting around the 50s.
Even though mercury stopped being used in the 60s, there are continuous ongoing low-level releases even to this day.
Now during that time, waterways were impacted too.
They needed flat land for all the infrastructure and buildings that they needed to develop, so they regraded the land, and the water has to go somewhere. You can't just get rid of the water, so that's why they piped the streams and then regraded the land over top of the streams.
Which makes the system here look like this. A complicated and intricate maze. To track mercury, scientists first had to map out the waterways.
We had to develop a very specific understanding of where are the hotspots of mercury in the system. How is mercury flowing? What are the pathways for flow?
Their research is leading to technologies that can immobilize this slippery element from dispersing in the environment. Part of that plan was sending out sorbents, or materials that would absorb some of that mercury.
We had a student that actually deployed some of these sorbents.
From there, it's a long-term study.
We're actually deploying them in the field and then looking at what happens to the sorbents over time, over the period of a year.
For more than 3 decades, the Department of Energy has focused on controlling sources of mercury in East Tennessee.
Mercury is one of the most complex environmental problems that the Department of Energy faces, especially here at the Oak Ridge site.
But with a national lab here, so is the perfect team to take on such complex research.
We can't just have one set of expertise. We really need to be leveraging on the expertise of many diverse fields. And that is the strength of working at a national lab.
Mapping the water flow, tracking mercury, and developing models take all sorts of experts, from chemists to ecologists to climatologists and more.
The right side, how different particle moves through the system.
Together, they are working to better understand how it moves and changes in the environment. That understanding will help EM use the right technology to control and eliminate it to keep us and the environment safe.
And this is very specific to East Fork Poplar Creek, but because mercury is a global pollutant, many of the lessons that we're learning here can be applied to other contaminated sites.
The work in here will most certainly spread out there. Now, there are 3 guiding goals with this work: reduce mercury concentration in water, reduce flux of mercury, and reduce concentrations in fish.